In our last video, I introduced the idea of an object, and in particular I told you we're going to use objects in their simplest possible form as just this idea of bundling data together. And so far we've seen bundling two integers together, an x and a y coordinate, to form a point object, and we created a point object so that we could actually find the midpoint of 2 points and return a point that had an x and a y value bundled together. And so we're getting there. So this is what it looks like to create a file that defines what it means to be a point, that a point is something with x and y, which I've made both integers, and those two variables are called fields, and this thing here is called a class. And when we use that, we write something like p equals new point, p.x equals 3, and p refers to now a point object, and p is an instance of the point class. And we said what we've done really is we've defined a new type of thing. In addition to integers and booleans and what have you, we also now have this idea of a point, and a point has integers inside it. And the syntax for working with it looks like this: make a new point, access the value in the x-coordinate, or maybe assign to the value in the x-coordinate. And I want to point out that the thing to the left of the dot, we shouldn't get too used to that thing being a variable. It could actually be something a lot hairier, as long as the thing to the left of the dot is an expression that evaluates to being an object that has a field with that name. So we'll see that soon enough, but let's write a method that works with these points. Let's get some practice. So here we go. Public static point. I'm writing a method that returns a point. We wanted to see what that would look like. I'm going to call it create point, because that's what this method is going to do. All this method is going to do is it's going to take two integer values and bundle them up together to form one of these point objects. So how do we do that? Well, first we want to create a point. And notice, so now I'm using the word point as a return type. I can do that. So here's a variable p that could refer to a point, but doesn't yet. Right now p does. There are no points. I have not created a point yet. This line, when I say new point, and I happen to be storing it in p, that's the moment I create a point. By the way, this would be a good time to point out that I'm using a convention in Java, and that's I always name my classes with a capital letter, to begin with a capital letter. So as a rule of thumb, everything in Java begins with a lowercase letter, except names of classes. And that's consistent with what we've seen so far, because a class will be the only thing in a file, right? So point.java, that's the name of a file. Point is the name of the class, but it's also the name of the file. And so far, this is consistent with this idea that file names have capital letters. So, all right, let's come back down. See if I can find my cursor again. Okay, so we made the point. We made a point. Yeah, I'm making a lot of points here. And I want to store this x value inside of this point. So how do I bundle this x and y value inside that point? I use this notation here. Inside of p, in p's x field should get the value of the x that I was passed in. And there's no confusion about which x is x, or which x is which, right? X unqualified is the parameter. X qualified by p is the x inside of the point p. Let's see, we'll do the same thing with y, and when we're all done, we want to return that x and y coordinate. And note, we can't do any garbage like this, right? There's no such notation in Java to just bundle things together with parentheses. You must be thinking of another crazy language. But I can return my point. Okay, so this method will create a point object. And that's great, because now I can write that midpoint method that we started a long time ago. Let's finish that out. We were making a method called midpoint, I believe, and it took in some integers. But if you think about it, it doesn't need to take in integers, right? It should actually, probably I think it took in x1, y1, x2, y2. But this is getting silly, because I don't want to pass a bunch of x's and y's around. I can pass points around. So we'll make it take in 2 points, p and q. And then what does the midpoint method have to do? Well, it needs to make a point whose x-coordinate is the average of p and q's x-coordinate, and whose y-coordinate is the average of p's y-coordinate with q's y-coordinate. And we could do that by writing out a bunch of code like we just did. Make a point right? Point mid equals new point. Mid's x should be the average of p's x and q's x. Mid y should be the average of, let's see, p's y and q's y, and then return mid. But actually, there's a nicer way I can write all of this, right? Because I just wrote this method that takes in two integers and bundles them together in a point, so I can use that idea. If you know something about working with objects, if you know too much relative to where I'm at in my video, you may know that what I've done here is I've defined something that is playing the role of something that we'll later create called a constructor, but I think this is a lot easier to think about at first. So all I want to do is create a point, so I'll call my create point method, which takes in an x-coordinate, and the x-coordinate of the midpoint that I'm creating should be the average of p's x and q's x, and the y-coordinate should be the average of p's y with q's y. I'll make this look pretty in a moment. And then we'll just return that point we created. So let's see. There we go. Create a point with these two numbers as its coordinates and return that point we just created. So that's kind of nice. Alright, what else can we do? Well, let's take a look at some of the more subtle things about working with points or working with objects, such as my point object. I'm going to start a new screen. Bear with me. Okay. And what are we going to do on this screen? We're going to say, well, we'll create another example here. P is, we'll create a point with 3 and 5. Now, what's the value if I now ask, what is p dot x? Well, p dot x should be 3, right? Okay, what if I ask create point 74 dot x? Can I do that? Can we say create point 74x? Sure, because create point 74 is an expression that evaluates to being a point object, and I can then ask the point object for its x-coordinate, and I think you can guess what that x-coordinate should evaluate to be, right? It should be 7. Okay, let's keep going though. What else can we do? What is create point 74 itself? What is that? What do I get back from that expression? I get a point object. Evaluates to a particular point object, which doesn't fit on my screen. There we go. And in reality, what it really does is it evaluates to be the memory address of a point object. The memory address where a point object exists in memory. And so we're going to talk more about memory addresses because most of the things that are subtle about objects are perfectly explained when you know that an object, when I'm working with an object, I'm really working with a memory address. When I pass an object to a method, like I did way down, sorry to make you dizzy here. When I pass objects to my midpoint method, I'm really passing a memory address to my midpoint method. And when I return an object, I'm really returning a memory address. It's a memory address in the sense that I don't want to think of it as a number that I can then add and subtract from. I can't do things like that in Java. But I think if you think of it sometimes as just as really being a memory address that you're working with, let me go back to where I was, that might help explain some of the seemingly funny behavior of working with objects. So for example, if we now ask p equals create point 35. So I'm comparing, that's two equal signs here, although for some reason it's connecting them in this font. I'm comparing, does p equal this point I created with 35? Well, does it? It does not, right? It doesn't. Because this equals tests if same memory address. In other words, are they literally the same object? Not equivalent object. Are they literally the same place in memory? And they're not, right? Because p refers to a point I created with 3 and 5, and create point refers to a brand new point I just created with 3 and 5, so those can't possibly refer to the same point. Therefore, this is going to be false. Which is frustrating because maybe you want to know, are these 2 points equivalent? Do they have the same coordinates? So let's write a method that would do that. Public static, and it's going to return a true or false, so a Boolean value. Do, I'll call it same chords for same coordinates. Do these 2 points, excuse me, P and Q, have the same coordinates? Well, how would I figure out if 2 points have the same coordinates? I would simply reach in and check. Does P's x match Q's x? And is it also the case that P's y matches Q's y? And I'm going to take that expression and return its value. And so that will tell me, do P and Q have the same coordinates? So I can now, if I choose to, we can say same coordinates of P and create point 3,5. And since P was, I believe, created to be a point that stored 3 and 5, this should evaluate to true now. Okay. I think this is a good place to stop. In the next video, we'll start getting deeper and deeper into the subtleties of working with objects and references, and then we'll get away from point examples just in case you find points a bit boring. So stay tuned for working with maybe some porcupine objects or something more interesting.